You should see him.
Recording is on.
Oh, I can't talk about this. Recording is on.
Okay.
Keep talking, please. Into the microphone. Lean in.
All right. Well, I heard it. We'll see it. We'll see what. We'll see what Dave is going to buy me. Okay.
He was beaming like a little girl, skipping and hopping. So.
Okay. Well, let's get started. Good evening, everybody, and welcome to the September mixer. And as I said earlier, August weather. Just a preamble. Don't forget, all of our meetings are recorded and will be posted on our YouTube channel for public viewing. So by participating, you agree. Okay, tonight on the agenda we have Kevin with another segment of Cool Chips, and we have Drew that's going to talk about his antenna tuner project and his little journey there. And of course, we'll finish up with the roundtable. And if time's permitting, I'll show a schematic that I got going on of what I talked about earlier in the week, or last week, I guess it was. So we'll see how time goes. Okay, where is he? Well, there he is. Kevin, top right. You ready to go?
Yeah. Hang on here. Well,
I have to say one thing about the Cool Chip stuff. Ever since you started doing that, whenever I'm looking through this literature, these emails I get about new products and stuff like that, I'm always going there. Okay, is that a candidate for a Cool Chip, or should I send that off to Kevin?
Well, you should, because I never have enough ideas. So anyway,
I'll keep that in mind.
Beginning. Okay, everybody see that?
Yep.
Okay, and of course we have the obligatory XKCD cartoon. I thought it was pretty good. I like the two sheep in love thing. Really cool diode and a wave pool. Anyway, yeah. So for anybody that's interested, anyway, so this week is not really a chip; it's a capacitor, and I saw this and I thought, oh, that's cool. Maybe we could do something with this. Up to 30 volts at 36 farads. So it's got a substantial amount of energy, right? And it comes with a little connector. It's got like a module, like cell balancing, just like a lithium ion battery. It can, it balances the voltage between the capacitors, and because it has multiple capacitors in parallel, I guess, or series, whatever. And so, yeah, it's like a little sort of mini lithium ion battery, except it's made of capacitors. And they come in different voltages, 9 to 30, 0.15 to 36 farads, good up to 85 C at reduced capacity, and good for 500,000 charge cycles, well, half charge cycles, max rated voltage to half rated voltage. So, anyway, that sounds so good so far, but so here's one. It's like, this is the 18 volt one. I just picked that just because. So the biggest one is like, so it can put out 18 amps for 5 seconds. Yeah, sounds kind of cool. I mean, the little one even is 380 milliamps, not very big, but fair bit of leakage current though. And then I thought, well, what can we use this for? So if we say we charge it to 15 volts and it's good for 18 amps for 5 seconds. So if we have a receiver that operates at 0.1 amp, that gives us 18 divided by 0.1 times 5 seconds. So it's good for 900 seconds. But the voltage is linearly decreasing all the while it's charging, right? So say we get down to 7.5 and we have to cut it off at that point because maybe the radio doesn't work anymore. So now we're good for 450 seconds. So we can run a QRP radio for maybe 7 minutes or less, depending on your voltages. So maybe it's not so good anyway, but I'm sure somebody could come up with something useful for this thing to do. And then there's the price. So this is the DigiKey price as of today. And I'll put the link in there in case anybody else wants to go look at it. So it's probably going to be one of the most expensive backup devices you'll ever own, per amp hour, that is. So anyway, that was that's what I found this week, and I thought, oh, maybe it's useful for something, just not immediately apparent. So anyway,
Well, two things took my questions away. One was the price tag, and then you already went. Yeah.
Yeah.
Once you started to state the how long we're good at 18 amps, I thought, okay, so what are we down to if we're into a milliamp territory and stuff? But 7 minutes, okay. So if you bought about 5 or 6 of them, put them in parallel, and then had a solar panel, blah 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 blah.
Yeah,
About $82,000 per.
It's just I've never seen a 36 farad capacitor bank before. That's all. Right.
How big was it physically?
Let's see. It doesn't. So the biggest one is 126 grams, and it's just over 4 inches by just under 3 inches by about an inch.
Wow.
But for $100, you can get like a 5 amp hour, 12 volt RC lithium phosphate, iron battery bank for, about the same price or a little bit more maybe. So there's that.
I see Dave's got his hand up, but just before I turn over to Dave, I was just going to comment. When you see the size of capacitors they're doing and the values that are in there, I guess I shouldn't be surprised that they could have that size of a battery with all that capacity. But they're doing some pretty good stuff today. Dave, go ahead.
Yeah, I was going to say I could think of a couple of uses for that. The price turns me off completely.
Yeah.
But I could think of a couple of uses. One, Kevin, spot welder.
Oh,
right?
Yes.
Because,
that would be good. Yes.
Because you could take like all that energy, discharge it to do spot welding. Because that's what a lot of people are doing. They get a huge bank of capacitors, charge it up, and it doesn't matter if it's 12 volts. Still, all you need is the high current, right?
Yeah.
So you could do that. The other thing I thought of doing is using it if you were to maybe chain them together. You could do some kind of buck boost thing where you could get a higher voltage, potentially a higher voltage. If it was a continuous charge thing, maybe you could do something with that in a buck boost or a boost converter, something like that, because that's got a ton of storage. And so you can have it running. And if you just need to burst your power out of it, you're bursting your power, then you could potentially have it, charging continually. And then you discharge it. You're not discharging the whole thing to zero, but you're just pulling out some current intermittently. Yeah. Maybe, key down on a CW kind of thing, right? But you're still going to need it charging in the background.
Yeah, exactly.
Does it have a life cycle there? Does it talk about that in the data sheet? Like discharging cycles?
Yeah, 500,000.
500,000?
Yeah, half voltage cycles, which is way better than any lithium-ion battery.
I was just going to say, it'd be an interesting cost would be to cost out a battery bank, with those kind of specs that, to last, to keep something going. And then you take the maintenance, the cost of the batteries times whatever, and then this unit. Who knows? Maybe 82 grand is cheap.
Yeah, I think the leakage current is still a big consideration though. They show it at 11 milliamps. Leakage current 72 hours is rated at 11 milliamps. I'm not sure I understand that spec. If it's going to be 72 hour spec, why isn't it milliamp hours or something? But anyway, if it's leaking 11 milliamps continuously, it doesn't take long, and you're going to drastically affect the amount of charge in that bank. So anyway, but yeah, I just ran across that and I thought, oh, that's cool. I haven't really looked at. I knew they existed, but never really looked at them. So anyway, that's why I thought I'd just bring them to everybody's attention, and in case you have the urge and you want to spend $80 on a very expensive capacitor, knock yourself out.
Did you say $80? I thought it was 82,000.
No, $82. $82.60.
Oh, Eric will buy one for the club. Go ahead.
Yeah, like Dave mentioned about spot welding, when you build your own battery packs and you got to put on the flat bars, you can weld it with that thing instead of buying a $200 spot welder for batteries.
So The only problem with that is that the ESR on the that capacitor bank is 0.22 ohms. So 18 divided by 0.22. So you're going to be limited to about 80 amps peak. And even then it says the peak 1 second current is 32. So there's that as well. So maybe they would work. I don't know. Maybe you need a couple of together, a couple of them in parallel. I don't know.
Eric can let us know because he said he just bought 10. There you go.
Yeah, you bought 10, so he can try it out.
Go ahead, Dave.
Yeah, I just thought of another use for it. Kevin, have you seen those Pico balloons? They use super caps, which are that capacitor. I take it's pretty small, right? It's pretty lightweight. So what happens? They use these Pico. I'm off of mute, right? Yep. I gotta check these things. Yeah. So yeah, on the Pico balloons, they use super caps, and they have tiny little solar cells that charge them, and they slowly drain the power out of these super caps, and that without having a battery on board, and they can have these things circumnavigate the globe. I think the record is like 18 times. I know the guy in Toronto, I think his name's Dave. I think it's V3CKL. I think.
Yeah.
Sorry, is it CKL?
I think so. It is. I know for sure his name's Dave.
Yeah. So, and I know his record is 16 times circumnavigating the globe with a Pico balloon. So that capacitor could be, something used there. But again, the price is going to throw you off because those Pico balloons, you never get them back. So it's a one-time deal. You buy that cap and you're just throwing it away.
Yeah. Yeah.
Okay. Anybody else have a comment?
Could it be used to supplement pulse width modulation, where it stores a little bit of energy each pulse and then returns it back, so the original voltage or the original power requirement is less? Like the battery would last longer, you know what I mean? That makes sense?
Where's the extra energy coming from for the capacitor? Is it coming from the battery?
Yeah.
Or coming from an extra? If it's coming from the battery, then it's not going to last any longer.
Well, that's true, because energy is energy.
There's only the energy isn't changing. You're just distributing it differently. But
well, unless maybe you could use a lower voltage source and that would supplement to provide a higher voltage source.
Yeah, then you need something to kind of buck or boost the voltage up, and
yeah, kind of like what Dave was saying.
You're going to lose something there, but I don't know. It's not an exercise in trying to find implications. It's more like just I thought this was cool, and maybe somebody next time they have a problem, maybe this will help them solve it. I don't know.
Yeah,
and
pretty neat.
Maybe that's one of the applications.
Yeah. Well, thanks for sharing that. It's pretty interesting.
Not for 82 bucks.
And if anybody runs across something and you don't want to do the presentation, send it to me and I'll do a presentation on it.
You know what? If you really want to know that $82 isn't such a bad price, is think like I did for the first 5 minutes that it was 82,000. 82
It's all relative.
Nothing.
Yeah, it's like that's not even a tax then.
You can't even go out for dinner for that.
Yeah, no kidding, eh?
Yeah, we just went for lunch. We were down in Port Stanley about a month ago. My wife and I, we had fish and chips, 2 beers. It was over $90.
Yeah.
That's lunch.
Okay. Well, thanks for any other comments before we move on? Okay. Well, thank you, Kevin, and I'll keep in mind when I see some of this stuff. You won't mind me forwarding it to you.
Oh, just drop it on an email or whatever.
Okay, sounds good. And the same goes with anybody else, I'm sure, too.
Yeah, exactly. Yeah, if you come across something and go, oh, that Kevin might be interested in that, just put it on the group if you want. Although it takes some of the mystery away, so send it to me directly if you want, and then present it.
Okay, thanks, Kevin. Drew, you ready?
Oh, as ready as I'm going to be. Let me just play around here and oh yeah, that worked well. Okay, so actually through SOAREX more than anything, I have been drawn into the QRP world. Something for which I thank you, because it's been a lot of fun building kits and the like. One of the things that I've been watching is these little manual tuners keep being suggested to me by Facebook and Amazon and eBay. And it's always the same tuner, never the same guy selling it, but always the same tuner. And it was cheap. It jumped in price in the last few months, but you know, $20, $25. I thought, well, why not? And of course, Peter is always talking about how you have to earn your stripes by doing toroids. It's a regular thing. So I ordered one, and it arrived as usual from China like the next day. And you get these parts. The thing in the upper left there is actually a plastic box. So, you know, for 20, 25 bucks, you're actually not doing badly. Got a couple of capacitors, toroid, a few bits and pieces, a couple of BNC connectors, so that's not bad. And so, that's all you get. Let's stop me for a second. And I actually sent the guy an email and I said, you know, this is very interesting, but do I get a hint? And he responded quickly and sent me a manual on how to assemble it, which I thought was very nice of him. And well, this is an example of the manual. And it suffers a bit. So, all things considered, you're kind of on your own. There are a lot of YouTube videos about this, and I'll get into that towards the end. But a lot of people have built them, and they didn't work. So, with that in mind, I stared at the only document that made any sense at all. This is what they send you for sure. And they repeatedly tell you to follow the diagram. Very careful about that. And actually, given the number of parts that are there, it's not hard to do. You have a printed circuit board. Everything on the left there is actually a little tiny circuit board that is a dummy load and that allows you to test for SWR. And you take it entirely out of the circuit once you've decided that your tuning is proper. And so you got one switch, double pull, double throw. Pretty straightforward. A couple of variable capacitors. The biggest problem is trying to fit it all in the box. You have to pay close attention, however, to T106-2, little dashed box over there. These are the instructions for winding the toroid. There's two. And they give you some enameled wire to wind it with. So, with this in mind, and not risking much, off I went. Ultimately, you end up with the big toroid. This is the challenge. Remember the diagram. We'll go back and just take a look at that. Each one of those numbers is the number of turns. Now, one of the things that I paid attention to was up in one of the videos, which I do have a link for, I'll put up on the chat. You will notice the number 10 at the top. The lady doing the assembly of this device, and she does, it's about a 25 or 35 minute video. She reversed that. And I followed her lead. So, bearing that in mind, the 10 turns are at the bottom, not at the top, when you take a look at the connection between the two capacitors. So they start you with this, and you end up with this. This took a long time. I have discovered that hot glue very effectively erases fingerprints. Zip ties do not hold it in place. And the diameter of the wire they gave me was bigger than the diameter of the wire in this picture by enough of a difference that it was pretty hard to jam in there. And to make it all that much more interesting, you get to solder it to this switch, which is a 12-position switch. So I made every use of every ugly soldering trick I could possibly use. And as long as no one looks too closely at it, I was actually able to get it on there. So the other part of it is they send you some decals that you're supposed to put on the box. This is for the assembly. You can see at the bottom there, it's kind of interesting. You end up doing a lot of assembly because there's no holes punched or anything. It's up to you. And fitting the interesting little circuit board into the top of it proved to be challenging. You'll see there's a little hole there where the light emitting diode pokes through. And they give you a hint you're supposed to bend it. And that works. It's fun because you're really making it up on your own. This is what it's supposed to look like. And this is not mine. Notice again that the diameter of the wire around the major toroid there, nicely spaced, looks quite nice. On the other hand, you'll notice that mine is somewhat more crowded. And that's the way it came, so off we went. It was a little tight, and at one point with the 10 turns, I wasn't quite sure that they should overlap. But anyways, that's my final assembly thing. Again, the dreaded hot glue gun. Now, for the results. I will draw your attention to the upper left graph only. The others are amusing, but not particularly interesting. The upper left graph, this is what my 20-meter fan dipole looks like without any tuner on it. And I've spanned there from 1.5 to about 35 megahertz. And it works very nicely. It's actually tuned for 6, 10, 15, and 20. So then I plugged in the tuner and just took a quick shot. Knocked the SWR down quite nicely all the way across, which really surprised me. And that's with some fiddling. And that is that little hokey $20 tuner tuning my fan dipole to about 3.6 megahertz. And just a little closer shot on that. So it worked very nicely, and it does work very nicely. It's meant for 5 watts. I don't think I would give it an ounce over that. But for 20 bucks, this thing will work on a QRP rig. The one thing I would suggest is that you don't rely on the little light emitting diode SWR checking thing at all. That you use a proper antenna analyzer to tune it. And then hook your QRP rig up, and I think you'd be quite safe. Anyways, that's what I've got.
Oh, that's interesting, Drew. I've got a couple of comments.
Yeah, I'm going to just, did I stop sharing?
Yep. Oh, I don't know. Yeah.
I'll go back and see people now.
Yeah.
I've never done that before, so that was different because.
Well, you're great. You're great at it, so we'll have to get you to do a lot more presentations, Drew. Was it a challenge to solder all those loops onto that switch, or did they line up for you? And yeah, you're muted. You're muted.
Yes, it was hideous. It was. I have a whole bunch of little hemostats and things like that, and so I would strip off pieces of wire that I have from a Bell telephone cable that are about 24 gauge, and I would wrap them around the lugs and solder the whole thing on occasion. It is ugly soldering at its best. It is horrible. I really hope nobody ever looks under the hood.
Well, it's a thing of beauty today. Dave, you
Well,
got your hand up? No, sorry. Go ahead, Drew.
Well, for 5 watts, $20 is a lot of. It's a lot of fun to build. I'll tell you that.
Well, I think the wire gauge you use to wrap around the toroid would give you a bit more than 5 watts, but hey.
Well, I think the capacitors were the question.
That's true. Yeah.
When I showed it around Carex there, they were all commenting on the capacitors looking like they've been all torn out of old AM radios.
Yeah.
And probably wouldn't take much in the way of energy.
Yeah, that's right. Yeah, if you put 20 watts into it, film it. Dave, you got a question, comment?
Yeah. So Drew,
Yeah.
one of the things that it's interesting. So I guess the way that you would use it, because you said that, you can't trust the red LED. So I guess what you would have to do if you're taking, I'm assuming you're taking it into the field,
yeah,
or even using it at home. If you've got multiple antennas, you'd have to tune it ahead of time and make a note as to where your caps and inductor needs to be. And then when you go to use the antenna, you'd have to set it to that setting, because you wouldn't be going and tuning it for each antenna each time you use it, because that would be tedious.
It would be. It's not uncommon though. I wouldn't, because I wouldn't do anything ahead of time, because we'll say you're going to work 40 meters. Let's just say you're going to go on 40 meters. You got an end fed set for 40 meters, and you've got it kind of tuned up at home. You're going to go out in the field, your conditions change. Now, you might have to alter the length of that antenna to get it to do 40 meters, or you could play with the tuner. But I would use an antenna analyzer like a nano VNA to verify the settings before I attach the radio to it. Just because the finals on these radios are kind of fragile, these little QRP rigs are cheap and they don't put a lot of money into protecting them. So I use an antenna analyzer. I've done this quite often with a variety of antennas. That before I hook the radio to it at all, I will run an antenna analyzer through the tuner and tune it that way.
Okay, gotcha. So with your nano VNA, can it do that in real time?
Well, actually, the pictures that I showed you were from the nano VNA, and as you change it, it changes.
Good. Okay, so then in the field or wherever, you'd have to connect your nano VNA or your MFJ analyzer, or whatever you've got, tune it to the antenna, then plug it to your radio and use it.
Yep.
Okay, got it.
I do that anyways. I don't trust the radio to dial it back far enough, and it's just out of habit. That's just the way I've always done it.
Yeah, especially if it's a homebrew rig, which may not have capabilities of showing you the SWR.
Well, I was warned off the red lead. Dave EAC told me that he thought it wouldn't be very sensitive, and that kind of corresponds with what people have said on YouTube about it. Is that if you get the lead thing to work at all, you're probably putting too much power through it.
Well, the other thing you could do too is if you maybe take away that LED. I don't think the LED serves any purpose other than measuring a current, showing a current going through there. You could put a resistor across that, put a op amp, and have the op amp put out a voltage proportional to the voltage difference. And that way you could feed it to a meter or a group of LEDs or something, yep, which can show you how far you're off. And as long as you know that when there's no current flowing, your your voltage across it should be this, or with a 1-to-1 match, the current flowing across the resistor should be this. Then that setting is 1-to-1. Then that this setting is a 2-to-1, or that setting is a 3-to-1, and that way you could eventually just tune it, because you know what the settings are. So that's another use. If that LED is not good, that's a perfect place to use a op amp.
Yeah, and I think Charlie XCC recommended just a 1 milliamp meter. Just put a meter on it.
Actually, speaking of meters, somebody at Carex had a whole box full of meters trying to get rid of.
Oh, really?
Yeah.
Well, Dave gave me one. It's so bad it's just a prop. Looks good though.
Yeah, Peter, I've got actually a box full of meters here too. I was looking to buy, I can't remember what Hamfest I was at, or maybe it was Dayton, and I was looking to buy 1 meter, and I picked out the meter, and I said, how much for this? He goes, I'll give you the whole box for the price of that meter. And he gave me a whole box of meters.
Excellent.
Maybe it isn't Carex that had the meters. Maybe it was Dave.
Might have been.
Maybe,
I put a link in the chat as for a YouTube video where it describes this entire unit. And the lady that did the work, she's very, very good. And she's the one who describes how the 10 turns should not be near the capacitors. They should be at the other end. I strongly recommend that if you're inclined. I mean, $20.
Why were you surprised, Drew, at the SWR you were getting, that it worked so well? Because it would only cost you $20 this unit? You didn't think it was going to work at all?
No, I didn't. And had I assembled it the way they said, it wouldn't have. The big trick was to have it. Once you reverse the windings on the toroid, the connection, then it works very well. And she actually, you'll enjoy this. Take a look at the video. She used LT Spice on it.
Who's the she? Do you remember her name?
I do not. I can give you her call sign though.
Yeah, what's the call sign?
Wait, one. KP4MD.
Okay, no, I don't know that one. Okay. Well, actually, if that box that Dave just showed was filled with meters.
Oh yeah. Well, that's a nice collection of meters, Dave.
There's a box of meters.
You need more meters.
Oh, I got another box here of static pads. Yeah, so that's the box full of meters. And unlike someone that we know, I can find stuff. I know exactly.
I wonder who that is.
Yeah, gee, I wonder who that is.
I've never met somebody that has so many different names. Okay, is there any other questions, comments for Drew? Do I have to mute Eric?
Jerry put.
Jerry, go ahead.
Yeah. So the core which came along with the kit, that was the one you used for the project, right?
Yes.
Yeah. Okay.
Yeah.
So
it comes with 2 cores, and I was just going to build it the way they said it and see what happened.
Okay. Thanks.
Yep.
Okay.
I will finalize with one comment. I do recommend you buy one and build one if you got a little QRP rig, because for $20 you can't lose.
You know, many years ago, I think it was the third homebrew project that we built many years ago. I brought it into breakfast there the other week. You're commenting the LED isn't very sensitive in that circuit that's in there. The LEDs that indicate the SWR on this particular rig, they work really, really well. And of course, it has a battery in there as well to help with that sort of thing.
Yeah.
But redo the circuit based on the design that's on that one.
Yep.
And that will give you your SWR indication there.
Yeah, I think the other side of it is you don't really know whether it's supposed to be glowing or not. They don't tell you that. It's very useful to have Google Translate, because a lot of the stuff that was on the labels arrived. It was in Chinese, Mandarin, I assuming. So I Google translated everything and then kind of interpreted what I saw. So
it's an adventure on a multitude of levels.
I'm going to assume that if it's glowing red, it's bad.
Frank, go ahead.
I think
There
he's
we go.
muted.
Just a comment on this kit that you just showed. And where is it? Oh, there it is. Same thing. Now you'll notice that there are 4 LEDs at the top. And when you have a good SWR, that they all turn off. So it's even calibrated to what the SWR is based on each one of those LEDs. And instead of the rotary switch, we have 7 toggle switches, and they're combined in a binary fashion. So, and then the big knob is just a single capacitor. But we built quite a few of those at the time, and I still use mine to this day. Of course, I only operate QRP, but it's been a real good piece of equipment.
Well, I think that's very much an upgrade from what I built.
I have to make a comment to what Frank was saying there. When Frank said a while back that he was going to buy a KX2, I said to him, Frank, the Elecraft automatic tuners are fantastic. They'll tune absolutely anything. So make sure when you order your KX2, order the ATU unit for it. And Frank said, nope, my homebrew tuner that we built all those years ago works plenty good enough. Of course, you saved yourself a few $100s too. Those tuners aren't cheap. Eric, you have a comment?
Here we are. I'll actually come on video too here as well. Hopefully that'll work, but maybe, I don't know, whatever. Anyway.
Over the camera.
Supposed to be working. There we go. Did you document your modifications?
I actually just followed along with the video. So I followed their documentation.
Okay, all right. Fair enough. Like, did you have to make any modifications to the video?
No.
Instructions? No?
No. The major deviation was flipping the toroid connection. The rest of it's pretty well stock. I will tell you that winding the 2 turns and the 5 turns on the little toroid was kind of entertaining too. Again, it's a great experience to learn how much hot glue you can take. Because it got it pretty bizarre. Anyways, yeah, the little toroid's really annoying, and trying to get it on the circuit board, certain amount of calisthenics involved there. The large toroid, it was just a matter of remembering what you had just done. So once you start, that's the problem. You've got all those taps to build, and winding the little tap so you can eventually solder it to a contact. It doesn't occur to you right away that they should be equal spacing so that it'll fit on the switch. And so that tends to be a challenge. The other challenge is getting the enamel off the wire once you wound it. The good news is this enamel burned off with enough heat. So that solved itself.
Okay, and the video that you used for it, was that something you found readily, or was it linked to the product?
Oh, it's not linked at all.
No.
I don't think the fellow who sold it to me would want it to be linked.
Oh, okay.
It wasn't what I would call generous with its praise.
Okay. Right.
They take it on as it is, and
As
there
is.
you go. And
Yeah.
there's a lot of discussion. I didn't get into it tonight, but there's a lot of discussion in that video about the knobs for the capacitors, because that one's not obvious. It takes a bit to kind of figure out what they want you to do, but those knobs don't fit on the capacitors. So they send you a bolt and a couple of washers and a couple of nuts. And what they want you to do is punch the bolt through the top of the gray knob and then feed it into the capacitor. And if you don't use any thread locking material, you'll discover that you can only tune it in one direction, because when you turn it backwards, the screw comes off in your hand. And so, when you use it, you carry a small Phillips screwdriver with you at all times. I mean, it's a bit of an adventure. It's $20.
Adventure.
It is. So I think, Eric, you should build one.
All right. Well, there you go.
Well, you were playing around with this massive, bizarre antenna that you've got.
Right.
And I was thinking of you the whole time, that this would be a perfect device for you to match up.
Well, I'll have some associated comments in the round table.
Just remember, 5 watts. 5.
Yes. Oh yeah. Yeah.
Not 6. 5.
With my current antenna farm, you'll soon see why that's the case.
Oh, okay.
All right. Okay. Well, thanks, Drew, for that. That's a very interesting build. It's amazing the journey that you can take on something so simple, you would think, or straightforward, you would think. Cherry, you have a comment?
Yeah, there are a few photos of that lady had actually posted a few photos in the YouTube comments, I think, in the description. So I put that link here. Apart from that, I think somebody also had 3D printed that capacitor shaft, and the design is there in that link, in that same link I posted. It's down below. But somebody had actually designed a shaft for that capacitor as well.
Oh, okay.
That's pretty interesting.
There's always somebody out there that'll do stuff.
Yeah, and then they have shared that for the 3D for the 3D printing. They have shared that STL file.
There's a lot of mods for it. I guess it's a good starting point.
Yeah, for sure. Okay. All right. Well, moving along. Thanks, Drew, for that. Appreciate it.
Yeah, glad to.
Okay. I think we've got the roundtable coming up, but before we get into the roundtable, let me just share my schematic and just see if I can get a couple of comments from anybody, if anything, and then we'll go on to the roundtable. We can see that?
Yeah.
Yep.
So this area here that I'm circling, that's actually the poor man's active probe circuit, and it works fine. It actually, Dave, you were talking about how the MOSFETs are not very accurate, models aren't accurate. Well, it turns this here actually is pretty much the results in the SPICE is about the same of what I was getting in the real world. So that was interesting, but maybe that's a fluke. Anyway, so I did this circuit, and then I took another circuit, which is this one over here, which is using the AD8007 op amp, and this circuit I think is pretty much the circuit that you would either see in the data sheet or even in the Midnight Designs on their DDS60 board. Anyway, so what I was talking about on the groups there the other day was this is 50 ohms here, and then the circuit design on this side here is 200. What would be the best way to connect these two circuits together? And that's what I was on about, matching 50 to 200. Now, because of what we're doing here as an active probe, I was kind of wanting to avoid coils, inductors, capacitors, that kind of thing. That's where I was coming from. So I don't know if anybody has a comment about that or not.
Yeah, I have a comment.
Yeah, go ahead, Hassan.
Best way to do it is to delete those resistors. Why do you only need a gain setting resistor, some kind of a gain resistor for R4. You don't need the 200 at all.
Okay, so get rid of R10.
Probably, yeah.
Okay.
And R4, I don't know what that has to be. Maybe it doesn't have to be anything.
Well, the R4 from the original circuit gave the 50 ohm impedance because this original circuit here would be feeding a 50 ohm, like your spectrum analyzer or the scope, whatever, right?
Right. So why do you need the op amps then? Why don't you just?
Well, because the circuit only goes down to, I can't remember now. What did I get down to? Minus 50, 60. I can't remember now. dBm. I want to get down to minus 100, 110.
Ah, in that case, you don't need the R4 at all either. Your U1 will be a unity gain thing.
Yeah.
And you just feed it directly into your op amps.
Okay, so I'll go from here. Get rid of. I'll leave the caps in. Get rid of them too.
I assume you would, but you may not need them either.
Oh, okay. I'm hearing other beeps away there, but I can't see in my screen that who else has a comment.
I think Dave was.
Yeah, it's on these. If you look the data sheet for these op amps, they're required to have some input resistance feeding them. You can't just have them flat going in. It's not a regular op amp. You must have some input resistance feeding them. Don't know why, but if you don't have that 200 ohms or a resistor like that, they don't work very well.
Oh. Then you keep the R10, but you adjust the value.
Keep R10 and remove R4.
Yeah. But
okay.
Yeah.
Keep in mind also too, R4 is probably setting the current through that MOSFET is limiting. That resistor R4 could be, what's it called? What's it called? Where it stabilizes it based on temperature. What's it called?
The feedback resistor.
There's a term for it. No, there's a term for it.
Well, if I recall, that R4 was setting. Well, the 47 ohms was picked in particular to set a 50 ohm impedance.
Well, also too, Peter, these MOSFETs, whatever they got, the GM, value is going to change with temperature. As these get hot, more current flows through them, just like a BJT. So you put a resistor in the emitter or the source, and that sets the voltage at that junction where you've got C5. It sets the voltage there, and from there, the gate voltage is fixed. So that's what a lot of those, it's emitter degeneration or something like that. There's a term for it, and it's used for keeping the beta of a transistor stable. And in this case, it's not beta, it's the transconductance GM. So you got to be careful. That R4 resistor could be doing some kind of stabilization for that MOSFET.
I mean, to my way of thinking, you're going to need that resistor in there. I mean, V plus will be going straight through without anything.
Emitter degeneration resistors are 10 ohms or less. They're not 47. 47 was meant to match it to a coax, which you're not doing.
Yes, that is correct. The output of C5 and C4 would be a coax.
Right. So you can use a smaller resistor then. You may need to spice it to figure out what it should be.
Because I know the data sheet calls for the 200 ohm resistor, like R10 and R15.
Yeah.
So you're suggesting maybe reduce the R4 down to 10 or something?
Yeah, and make it so that you touch the MOSFET with your finger when you're using the probe, so it's guaranteed to be 37 degrees Celsius.
Now, but you see, but my question really originally was matching the circuit part on the left, in other words, R4 to R10. Are we basically saying don't worry about it?
Yes.
Okay.
You don't need to match over small distances. You only need, over small distances, you don't need to worry about the matching problem. You really just have to worry about attenuation.
What about power transfer? What about power transfer? Because you got such small signals here. You want to transfer as much power as you can or as much current as you can, right? So if you don't have it matched, couldn't you not be transferring the amount of power, and you may not be getting, as you said, you may get attenuation?
Yeah, you only worry about power transfer when you have large amount, when it's a power amplifier. In this case, you worry about voltage attenuation for a small signal circuit like this. And so you just do it so that you attenuate the voltage as little as possible. That's what you should be worried about. Power transfer is irrelevant because there's tiny amounts of power going through here.
Well, you're right. The output of that circuit on the left is you divide the input voltage by 10.
Yeah, hang on a second. Let's explore this a little bit more. Okay, so Hassan, in the case of an antenna, you've
Right.
got a 50 ohm antenna. You've got a really weak signal coming in through that antenna, and you're going to pass it through a mixer or an amp. If you've got an impedance mismatch, not all the power from that antenna is being transferred to the next stage, so you're going to be hearing a weaker signal.
Yes, but power transfer, impedance matching really only matters for the transmitter. For the receiver, power transfer is not the important thing. Because then when you have perfectly matched 50 ohm into a 50 ohm, you have max power, but your voltage is attenuated by a half, right? So if you're worried about small signals, you really try to keep the attenuation as little as possible. You do not worry about a thing. I mean, it happens to be this is the way it is. And there's another thing. If you want to get minimum noise, that is a different set point. That's called noise matching. That's what you do for low noise amplifiers. So depending on what you're doing, a power stage, you match the power because you don't want to lose any. For a small signal amplifier, you reduce. You try to get the voltage attenuation the least, and for a low noise amplifier, you try to get the noise matching to be so you have the least amount of noise in the circuit, and that's one of the trade-offs you have to do. That's why you have 3 different types of amplifiers: LNAs, signal boosters, and power amplifiers.
And I guess
differently.
Hassan, it depends on what your subsequent stage is looking for. If it's looking for voltage, then that's a different story. If it's looking for power, then that's a different story. And if it's looking for current, that's a different situation. So each one of those situations, you're going to have the appropriate matching, right?
That's right. Yeah, so in this case, it's an oscilloscope. So you're probably not worried about low noise. You're probably looking for just signal amplification. So it's a small signal amplifier. So you really just want to make sure the voltage is not attenuated as least as possible.
See, another
and I
reason
guess since it's an op amp, you're not looking for power because theoretically no current flows into the amp. It's only looking at voltage. Right. So in this case, you're actually looking for voltage that's going into that 8007, right?
That's right.
See, the other reason
you're
why
trying to get voltage. Sorry, go ahead.
I was going to say the other reason why I bring this up as well, before I go any further with this particular design, because the simulations, as you see this circuit now, goes into, I've got the simulation time down to about 1.5 hours, I think. So, every time you make a change, you don't get the results for another, say, a couple of hours, right?
Why?
Well, I'm also sampling from very low voltages up so I can get a good graph of what's going on at each level. And that takes a lot of calculations, because when you look at your charts for each dBm of change, you don't have to change very much. The voltage levels don't vary a whole lot to change from one dBm to another.
Yeah, it's a linear circuit, so you don't need to worry about. You really want to sweep the frequency. You don't need to redo the simulation for different voltage levels, do you?
Well, I do, because I want to make sure it's linear. And I know at a certain point the 8807 starts to knee over. I forget at what level. I mean, it's nowhere near. I don't know why it's doing it, because it does it nowhere near the rails. But nonetheless.
Well,
for example, if you're going to check what it's doing at minus 110 dBm, and then go to 109 dBm, you're talking like 0.2 microvolt. So if you want to test every dBm level, that's a lot of voltage checks. Anyway, that's one of the
endpoint.
Sorry?
You just need like 3 points, the top, the bottom, and the middle. You don't need to do like every point in between.
Yeah, I thought of that.
The real issue is frequency. You're going to have different attenuation with different frequencies, but that's what AC analysis is. That's pretty quick. So that's the one you have to be worried about. Is it linear across frequency? Linear across voltage is less of a concern.
Actually, in some ways, I think they'd be both a concern. But anyway, so now, was there any? I heard the thing going away. Was there anybody else wanting to make a comment? I can't see the screen.
Yeah, me.
Yeah, go ahead, Ken.
Why don't you just do what Farhan does with all the bit axes? He just uses a 200 ohm attenuator to force a match. Because you're going to be using amplifiers anyways, and that's exactly what Farhan was doing. So instead of him trying to match a 200 to a 50, he would just use a 50 attenuator followed by an IF amplifier or whatever the case may be.
I'm not sure I want to add another amplifier in there, though.
No. But just take that 200 out and just put a 200 attenuator. Build it at what, 2 dB or 3 dB, and then you got 2 amplifiers following it.
Oh, put it like a pad. You know what? I started to look at that, and then it came back and said, "Oh no, the dB." I started like that, like 1 dB, 2 dB, 3 dB, and the calculator kept saying, "No, the dB levels are not high enough to warrant what you're trying to do." And I think it finally came in at around 11 or 12 dB loss.
25.
Pardon me?
25 dB. If you're matching 50 to 200, it's probably upwards of about 20 dB. It needs a huge amount of dB.
And I thought that was a bit much. Considering where I'm starting from, like I say, I want to start down around. I'm hoping to be able to read like a couple of microvolts or better. Anyway, that's where we're at.
Anyway, Peter, I've got another comment. I got a couple other comments.
Yep.
Okay, coming back to what Hassan said, because this is a voltage device, you don't need power. This probably should work just fine, because you don't care about matching. You don't care about power transfer, and in terms of the trace lengths, you're not going to have any reflection because the traces are so small. You've got, how big is a 7 megahertz wavelength? That's 40 meters, right?
40 meters. Yeah.
So 40 meters. So you've got a fraction, like, millimeters compared to 40 millimeters. You're not going to get much reflection. So the only time you need to match resistors is to do power transfer. And in this case, that amplifier is a voltage amplifier. It's only looking, check the data sheet to make sure it should have an input impedance specification. And if the input impedance is something really high, like, hundreds of K or mega ohms, then power is irrelevant.
Yeah. Okay.
So the next thing is, you're saying that this simulation is slow. Why are you running it at 200 microseconds and you're saving it at 100 microseconds? Why are you running it for so long?
To be honest with you,
because at 7 megahertz, what's the period of a 7 megahertz signal? That's like nanoseconds, right?
Mm-hmm.
So you could get away by running this for, like, say 1 microseconds or 2 microseconds.
Okay, I'll try that. To be honest with you, Dave, I've been at this now for about over 2 weeks, and I've now lost track of what I was done before. So I couldn't answer to you why I settled with 200. I know one thing though. I did play a lot with those numbers, and I end up settling for there. But I will go back and start over and try
Because
what you recommend.
the only time you need a large simulation time is when the circuit needs to converge or start up. Like, for example, a crystal oscillator. If you look at, over 1 microsecond of a crystal oscillator startup in LT Spice, you'll see it starting out slowly and then it gets bigger, 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 and then it gets stable. That's what I'm saying, converge. It needs to converge.
Well, I
It
know I
needs
have a lot of, I do
become
get a lot of
stable.
errors.
So if, like, for some reason this circuit needs, say, 100 microseconds to become stable, then okay, fine, I buy that. But I think it's excessively long. I think you could get away with a couple of microseconds.
All right, we'll try it. I know I have a lot of DEF CON errors, but anyway.
And that's probably because of your models. You have for the, like, I'm sure the BF 998, the AD 8007, those are models you got off of the internet, right?
Well, the AD 8007 came directly from Analog Devices. And
Right.
the BF 998, I can't remember. Well, you're right.
And it's a sub-circuit, right? And it's a sub-circuit. If you open it up, it's text, it's a sub-circuit, right?
What, the 8007?
Yeah, if you open up the library file for it.
Oh, yeah.
Right? It's probably got a whole bunch of text and it's got a whole bunch of circuit descriptions, so it's a sub-circuit. Oh. So those things take a while. I'd be suspicious of that BF 998. That could be the thing that's taking a long time to stabilize. But anyway, those are just some tips to look at.
Okay, well, that's great. All right, well, thanks, guys. I appreciate the feedback on that, and we'll stay tuned. Okay.
Do you have the BF 998 with you?
Yeah, I got about 9 of them.
Oh, okay.
Yeah.
Cool. 9 spares.
And there's another story there, but that'll be for another day. Okay, well, we got 25 to 9, so we got time for a quick round of what's on our benches. So we'll keep our 9 o'clock deadline in mind here, guys. So I'll start off since I'm up on the upper left. And basically what you saw right there is what I've been playing with for about 3 weeks now. I've certainly learned a lot more about LT Spice going through all this stuff and, how to speed up. When I originally started into this, actually, if you simulated the first stage on its own or the AD 807 stage on its own, simulation times are not all that long. Combine the two together, the sim times go ahead. Howard, you had a comment?
No, I hit that by mistake. Sorry, Peter.
Okay, no worries. I thought that was an interesting thing there, and so I got delayed with. I spent a lot of hours and time on how to speed up simulations and reading, etc. So anyway, that's what's been on my my bench for the last 3 weeks, anyways. Okay, next on my screen here is Drew. Anything other than antenna tuners for you, Drew?
Well, yeah. One of the things I've been working on for quite a length of time is a computer system for my boat because it's a toy. And so this is now, it's a 60-year-old sailboat. And right now for navigation, I use a CF27 computer, which is okay, but it's clunky and it draws a lot of power and it drains my car battery down to the point where a long trip it doesn't work very well. So Raspberry Pi, an interface board, a hat that provides it with 9 axes of motion plus GPS plus AIS reception. So it's a neat little computer system. And I've been working on it now for about 2 years. And now I'm getting to the point where it's almost ready to go. So it's kind of fun because it will actually drive the boat.
Well, you better hurry up, Drew, because the boat's gonna be pulled out of the water before you know it.
I got about a month, and so what can you say? It's been a fun project just to learn about it, and it's an application on a Raspberry Pi that I hadn't done before, and I've used the same basically the same navigation software all the way along. It's all Linux based. Okay. And so it's cheap charts and just playing around. That's what I've really been spending the last little while with, and I am doing some 3D printing because, in keeping with my theme, I have a miniature HAL to stick on the front of the computer panel, and it will be my idiot light. When the light's on, I know the computer's running, and it'll have a little red light, and HAL 9000 running my computer, my sailboat, because why not?
Why not? Very good, Drew.
So that's kind of what I got.
Okay, thank you. Eric, you have to say something like jump in the queue or what?
What's the LOA of your craft?
19 feet. Length overall is 25.3, and the water line's 19.
25, eh? Okay.
Yep.
Nice.
Yep.
Okay, next on my screen here, and it's not Eric, is Al.
Okay, well, I don't have a lot to report, actually. It's been a busy summer. Away for a while. Slowly getting back into things. Managed to get out onto the patio this weekend, do a little bit of QRP, which was fine. One thing I did do is I needed a new gel cell for running the QRP. So I went out to A1 and bought a 12 amp hour gel cell to run this. But it's kind of interesting. While I was there, I saw these little 0 to 40 volt LED modules. $10. Okay. Figured, what can I do with that? So here's what I ended up doing is I ended up a small box on top of the battery here, and little button. You check your voltage, and you can actually see I've got some voltage on there. It seems something trivial, but well, why not? Why not? So that kind of worked out okay. The only other thing I've been up to this weekend, I was fixing the antenna farm. The squirrels have been nibbling away at the ropes, and the ends of the dipole came down. So I got that back up and had a learning experience, so you might say. Got the new ropes in there, hoisted them up there, really happy with that, turned my back, and well, the center feed point of my dipole is on a mast lag bolted to my chimney. And I managed to pull a brick right out of the side of the chimney, and the whole thing came crashing down.
Oh my God. Yikes.
So, yeah, I've got to re-engineer that and get that back up. And, well, the chimney is suffering some extensive wear from, the mortar between the bricks is getting pretty poor. So I think it's time to bring in a contractor and get the chimney fixed. And so right now, my G5 RV is laying across the top of the roof with, and the ends are on the ground. So it still works. Anyhow, that's what I've been up to. A little bit of mechanical stuff and no real electronics or circuits right now. But now that we're getting to the fall, maybe I'll get into something more. So that's it for now.
That's enough you got, that's for sure. Ken, you got a comment there?
Yeah, I say if you can tune it, use it.
Yeah.
Absolutely.
Well, when we get back to our Monday night CWs, we'll there's the test. Actually, we might be shifting that. So anyway, okay. Thanks, Al. Eric, anything? Is there anything new with you?
Sure. Yeah, I've got two things. One, it seems that this farm that I live on is not very friendly to ham radio antennas because while I was away mid-August for the week, come back, and my last standing proper antenna, the inverted V horse fence, is on the ground, but not just fallen off, but actually torn out of its, where the feed point is. It's a horse fence, so it has the 4-conductor broad tape coming out of it. So that was, unfortunately, that's going to need a little bit more than just duct tape to get that back and running. But and also the coax at the feed point was ripped out, so that kind of munched the end of the coax as well. So anyway, I'm down to no antennas here other than a pack-tenna that nailed to the wall of the barn, and that's where I could use that little tuner. That would work. Tune up my random length end-fed little pack-tennas. And anyway, I actually took that on a camping trip a couple of weeks ago, and worked half decent as a receive antenna. Managed to receive Romania on it, but they were blasting out 200 kilowatts or something. So anyway, there you go. And what else? Not too much else. I was actually this afternoon, K8ZT, Anthony Luscre, I think his name is. He was doing a live presentation. He's very prolific in doing presentations for groups on many topics, and I'll post a link in the comments here, but he had a really good one titled Maps and Charts for Amateur Radio. And a lot of stuff that I'd never come across, a lot of stuff I knew, but there were some interesting things. I don't know if you're familiar with something called Grid Mapper on QRZ, but you can find local hams, and lo and behold, there's a ham at like a kilometer south of me. I never knew. So there might be a replacement for the ham that moved out of the area. By the way, Tyler is still listed as being at 13 or 14 Cedar Mills or whatever it was. But anyway, kind of cool. Shows you in your vicinity. I think it's by Grid Square how many hams are on QRZ. So that was neat. But there you go.
Okay. Well, thanks for that, Eric. I thought after what Al was saying, you're going to one-up him by saying that your antenna, the whole side of the barn came down. But okay. Frank, you're up next.
There we go. I spent all my hobby time, as it were, and limited as well, on the HW9. It passed the smoke test and with flying colors, but I'm having difficulty getting the alignment done on it. And they have kind of a unique way to align everything. Normally with a rig that I would build and check out, I would go from the headphones backwards and troubleshoot it that way. This one starts at the antenna and goes forward. And every once in a while, I'll go to make an adjustment, and there's nothing there. So I pull the board out and have to do some troubleshooting on the board to get that particular circuit running. And that's just been a variety of different things. One as simple as the slug in the coil was too far out of adjustment that the oscillator didn't oscillate. Other ones are maybe some solder problems, but I'll show you. There it is.
Nice.
Yeah.
That's cool.
Very nice.
Saw one of those for sale.
There's the bottom. That's one board, and the other board's on the other side. This one I've had in and out probably a half a dozen times anyway. I'm getting good at it. So the other challenge that I see ahead of me is that it's showing its age because of the connections. And you'll see that the headphones is a big switchboard jack that you plug in. The key, instead of a nice 3.5 type device, it's an old RCA Victor plug. So I'm going to have to start making up some adapters and the power plug too. So I've got a few challenges yet, but it's been a lot of fun, and it has kept me busy, which is a good thing this last summer. So that's about it.
Okay, that looks good, Frank. It's nice seeing that stuff there. I'm glad you're making progress. Let's see who's next on my list here. Ken.
Good evening. Good evening. So the last, I don't know, spring, summer, I haven't been able to do much, but things are slowly getting back to normal. I was working on the QRP Labs 40 meter bandpass filter with a lot of problems. Couldn't get it to tune properly. For 40 meters, he Hans recommends putting 4 extra turns and then backing off the turns to get the bandpass aligned correctly. And it got to the point I had taken off 6 turns and it still wasn't set up properly. And I thought this was really, really weird. So I ended up pulling the trimmer caps off and made a measurement of them, and they're about 50 picofarads. But according to the instructions, it's supposed to be 30. So that would explain the extra turns being taken off. But anyways, I got it working now. The caps that come with it, I prefer because they're the ceramic type, and there's a negative temperature coefficient on those. So they're a lot more stable. Other than that, on the bench, that's pretty much it. I had also this past weekend purchased this little baby, and I'm going to stick it in the chat. I bought myself an FT891.
Ooh.
I had a friend who I have a friend who has one. I tried it out. It's a 100-watt all mode HF plus 50 megahertz, and yeah, it went against my policy of not buying anything commercial, build my own. But the price had dropped $100, and I said, "What the heck? I'll treat myself." So that's what I picked up.
Okay, very good. Oh, wait to hear.
Ken, I got a question. Sorry, Peter. Ken, I got a question. That's very interesting. Maybe sometime you could just give a talk about it, because I'd like to hear. Because I've been looking at the 817. I guess that's the big brother of the 817.
Yeah. Well, with this one, with this model, there's only 2 rats. The reviews are excellent for this rig. No matter where you look up, everybody loves it. There's 2 issues. Previous Yaesu menu system is all alphabetical, whereas for some reason this one, it's doing it by a menu tag number. So when you go through the menu, it's not alphabetical at all. So you have to search for it. The other rant is that with the other Yaesu's portables like this, they always have the battery voltage on the bottom right corner of the screen. This one doesn't have it. The only time you actually see your battery voltage is when you first turn it on. But other than that, people love it.
Yeah, because I'd like to know what voltage it runs at, power output, just your thoughts. Because I guess, have you gotten it yet, or you gonna have it set up soon, or?
No, I've got it. I just haven't gone through it yet.
Okay, because it'd be interesting, because I've been looking at that radio at Dayton. I went down to Dayton last year, and I was looking at it in the Yaesu booth. I was going, oh man. It's
Yeah.
like I walk by and I look at it and I touch it and I go, ooh, nice. And I pet it.
Well, you know that when I go camping, I take my boat anchor FT 450 with me. It's not huge, but it's not small. This one's probably a third of the size.
Yeah. So I'd be really interested to hear, Ken, what your thoughts and feedback is on that, because that's a radio, even the 817. I've been looking at that. The only turn off I got about the 817 is the little hokey battery pack it's got.
Yeah. The only other drawback too is this doesn't have a built-in tuner, but I don't care because I've got an auto tuner that's probably a little larger than that, so I'll just sit it on top. I really don't care.
Okay, Drew's got a question here, I think, and we're also starting to run a little bit short of time. We got a couple more guys to go through. So, Drew, what you got going? Question?
Well, the 891 is 100 watts. I think the 817 is 5, isn't it?
I believe so, yeah.
Yeah, and it does 2 and 70.
It's 5 watts. I think it's 5 watts. If you've got the internal battery pack, I don't even think it's 5 watts. I think it's only unless you got an external 12-volt battery, or there's something hokey like that.
That's correct. Yeah, it's 2.5, I believe, with the internal.
Yeah, the 891 is 100 watts.
Okay. Okay, thanks, Ken. Cherry, you're up next. Oh, the cherry just dropped off. Okay, maybe you'll come back. Hassan, in the meantime, then you're up next.
Okay, nothing to report. I was gonna put my dipole up, but that'll have to wait till another weekend. So yeah, nothing major.
Okay, so you're gonna wait for it to rain. Okay, Hassan.
Yes.
Smart ploy. Okay, thanks for that. Cherry, you're up next.
Yeah, I got disconnected somehow. I'm not sure whether someone else is experiencing the same. I got twice disconnected in between. Okay. Anyways, on my bench, I finally completed my NFED half wave. And I tried the 80-meter, 80, 40, 20 multi-band antenna. I was really, really happy about it. I only felt that I should have completed it much, much long back. Instead, I was lazing around with this, and I tried with an 80-meter coil and a 20-meter length of wire. It was amazing performance. Perhaps it's also a presentation for or here for the next time. So I can save that for it. And I had a very good experience with 817. I never had this kind of happiness working with that. 817 and the Nano VNA was of very great help when I tried this out in my vacation to India. I had a pretty good time with this, and I like this. This is really good stuff. Though it was not very fine tuned, because once I started playing with it a little bit, 80-meter went off and I could not get 80-meter back, but I could still tune 40 and 20, which was amazing performance. On 20-meter I pushed 2.5 watt and had great contact. And a 40-meter also was equally good, but SWA was a little more better on 20-meter, which I was trying to fine tune, but I needed more time to get there, but it was amazing. I never thought this would be so fun, but this is really great. That's what I was doing.
Okay, well, thanks, Cherry. That's appreciate that. Dave, you got a question?
Yeah, Cherry, have you? I take it you haven't had time to play around with that Jim Veach amplifier you got. You haven't had
No,
time
I have not completed that. I have not completed that yet. That's one in the queue to complete. Yeah, I want to actually work on that pretty soon. Yeah, that's something on my list. Yeah, and thanks, Eric, for showing that battery. It is looking good.
because I'd like to find out how that
Yeah,
that,
I got
works
you.
out with the
Yeah,
amplifier.
yeah.
Okay, thanks, Cherry. Dave, you're last but not least.
Yeah, sure. I haven't been doing a heck of a lot because with summer here, with my camping and summer pests visiting, I haven't done anything. And it just the past week or so, I've gotten back into doing things. So I was able to finish off because I looked along a little bit getting my S-meter circuit for the Phoenix done. So I've got a presentation on that I'll be giving at the next, I guess.
Yeah, you're on tap on the 20th. I think.
So I've got so I've been kind of working on that, and as well now I'm switching gears and I'm working on a presentation for the Miller effect, and got some surprising and very disconcerting findings about LT Spice that I'll share. But I'll be doing that presentation probably in October. So that's kind of what I'm working at. I haven't melted solder in months.
Yeah, I know what you're saying there. Neither have I, actually. Okay. All right, that's everybody on the list. I don't think I missed anybody. That's great.
I've got one last thing, Peter.
Yeah.
I don't know if anybody else is interested. I was thinking about going to the Carrick Hamfest October 14th. And if anybody else is interested, maybe we can carpool.
It's
Well, you're
actually
coming down to Kingston.
Carrick's.
What's that?
It's Carrick, not Carrick's.
It's Carrick. No.
Yeah,
Kingston
Kingston
Amateur
Amateur
Radio
Radio
Club.
Club, not Carrick's.
Isn't it?
Well,
It's
part
the
of it.
Kingston Amateur Radio Club is having the
okay.
Carrick's is an offshoot of the Cark group, something similar to what Homebrew was, Park Homebrew to the.
Oh, okay. Well,
just to clarify.
Oh, so you're coming to Kingston on the 14th?
Yeah, I'm thinking about it.
Oh yeah. Well, I'll have to get my wheelbarrow loaded up.
I'll bring Eric.
Excellent.
Hey, bring that tub of parts with you.
I always like deep pockets.
So, okay. Is there any other comments or anything?
That, by the way, that's October 14th, right? Not
Yeah.
September.
Yeah, 14th. October 14th.
October.
Yeah, I will be there as well. Yeah.
No, you're a Hamfest junkie, Cherry, just like Mike is. Of course, you're going to be there.
Yeah, unfortunately, I missed quite many when I was in India for a couple of months. Yeah.
You're coming all the way to Kingston. Wow.
Okay.
That will be very exciting.
Not that far away.
That's true.
You're going to be camping, Eric.
On the 14th of October?
Yeah, isn't that the fall trip?
Oh, you're right. Correct. Yep.
Cancel.
Well, actually, we're not that far from Kingston, really, Dave. If you think
Well, you could paddle. You could portage. You could take
right on the
portage over. No problem.
I have a feeling I might get whacked so hard with a paddle that I'll be flung into Kingston.
We're
from
right on the Rideau Canal, so there's no reason why you can't portage and paddle.
Hey, it's like stopping at Harbor Freight on the way to Dayton.
Yeah.
I'm afraid.
Okay, I'll go over the schedule for presentations coming up. I think might have to jockey a couple things around there, guys. Drew and can't think of who else there. Anyways, I'll be in touch as to what we're doing.
Yep.
I think at the moment we don't have anything scheduled for December, and I think we have an opening in November. So I think, Cherry, you mentioned you might have something. So if you do, drop me a line. And, we'll see if pitch in there somewhere. If anybody else has got something they want to present or talk about, whether it be 5 minutes, 10 minutes, 15 minutes, whatever, a half hour, let us know. Okay, guys, thanks very much for joining us tonight. Much appreciated. And I guess we'll see you on the 20th. Well, we'll talk to you before then. And good night.
Good night, guys.
Hi, all.
All right.
Bye.
73 all.
73.
Easy.
You know, Eric, they can probably, if you go paddling down the canal, they should probably hit you on the other side of the face.